Okay, this is section 2.4 and 2.5. This is on deductive reasoning. Now all this is going to be your definitions. You'll have another video to watch that'll be all of the postulates. So for this first one, we've just got 4 definitions. Our first one is deductive reasoning. And deductive reasoning uses facts, rules, definitions, properties, anything that we already know is true, something that you know can be true already, to reach a logical conclusion. Okay, now the example we're going to do in class that you'll see throughout the rest of the chapter are proofs, and proofs are good examples of deductive reasoning because you will start out with some statement and then you're going to have to work through using our theorems, our postulates, our facts, our rules, our definitions and properties to reach a conclusion. So a proof is a good example. Another example is a logic problem, okay? Because you're using the information they give you, which would be your rules and your facts and your rules, to reach a conclusion. Now, one you may be familiar with is the game Clue. Okay, Clue is an excellent example of deductive reasoning because you figure out all of the facts beforehand. You have cards. You figure out who killed so and so with the weapon in what room, and you deduce all of that by looking at the cards. And you ask questions to get there. So Clue is a good example. Now, a postulate, that's your second definition. A postulate is a basic idea of geometry. Okay? And it describes a fundamental relationship. Now, all the stuff that we know about points, lines, and planes, all of that stuff is postulates, and you're going to look at them in your next video. Okay? They're all basic ideas of geometry, and we put those into writing and we call them postulates. Now, something important is that postulates do not need to be proven. Okay? And that's important. Postulates we understand are true. They're all basic ideas, and we understand that they're true. We just need to put it down in writing so we can give them a name, but we don't need to prove them. Now, theorems are the opposite. Theorems, you need, you must prove them. Okay? And you can prove these using other postulates or theorems. Or definitions, facts, all that other stuff, but you prove them using deductive reasoning. And before you can use them, they have to be proven, okay? So you can only use these in proofs after they're proven. Now, a lot of the time in class, we're not going to prove all of these theorems. You just take my word for it that we will understand that we could prove them if we wanted to, but there will be a few that we do prove, but most of the theorems we go over in class, we're not going to go ahead and prove. But if we were going through like a college geometry class or anything like that, we would have to prove them before we could use them in any other proof. Now, our last one is proof, and that's the word I just said, a proof. And a proof is a logical argument in which each statement is supported by a statement And those statements there, these ones here, are going to be postulates, theorems, definitions, rules, properties, those types of things that are accepted true. Okay, now the reason we need to prove theorems is so that we can use them in other proofs. Okay, I can't make a statement in a proof if I haven't proved the theorem I'm going to use to claim it. Okay, and we will talk later on, but the types of proofs that we're going to do in class are called two-column proofs. Alright, and it's just what it sounds. You have two columns, statement column and a reason column, and then we make a statement over here, and it's supported by either a theorem, another theorem, or a postulate, or a definition, or a rule, something that we already know that's true, that we've proven true, or we accept to be true. Alright, and those are your vocabulary words for section 2.4 and 2.5.